Welcome to another episode of the Tech Talk podcast, where we dive into the fascinating world of AI and machine learning. Today, we're exploring the exciting advancements made with DeepSeek, particularly their groundbreaking models, DeepSeek-R1 and DeepSeek-R10. So, let's jump right in. If you're familiar with the realm of AI, you know how crucial reasoning capabilities are for these models. Recently, DeepSeek introduced their first-generation reasoning models. What's particularly intriguing about DeepSeek R10 is that it was trained using large-scale reinforcement learning. That means it didn't undergo the conventional supervised fine-tuning phase before learning to reason. This model displayed some powerful reasoning behavior right out of the gate, but as with all things, there were bumps along the way. Now, imagine this. You've got a student who learns completely independently through trial and error rather than following a structured curriculum. Sounds liberating, right? That's the approach taken with DeepSeek R10. However, this model faced some challenges. Issues like endless repetition and language mixing emerged. It's a bit like if that student started off really creative but then found themselves stuck on the same topic over and over again. To tackle these hiccups, DeepSeek introduced DeepSeek-R1. This model builds on the successes of its predecessor by incorporating cold start data before diving into reinforcement learning. It's like giving that student a solid foundation while still letting them explore. And guess what? DeepSeek-R1 has been shown to give performance on par with OpenAI's models across a variety of tasks, including math and coding. Speaking of performance, one of the most fascinating aspects of this development is the distillation of larger models into smaller, more efficient ones. It's like translating a complex novel into a concise, easy-to-read summary while still keeping the essence of the story intact. These smaller models might surprise you with how well they can perform, so they've open-sourced a variety of these models, including sizes from 1.5 billion to 70 billion parameters. It's clear that they want to ensure that even smaller setups can harness the power of reasoning that their larger counterparts exhibit. Now let's take a moment to look at the evaluation results. This is where the rubber meets the road. They've conducted extensive benchmarks, and it turns out DeepSeek R1 consistently outperformed several established models on tasks ranging from math questions to complex coding challenges. Imagine sitting a bunch of AI models down for a competition, and DeepSeek R1 comes out ahead more often than not. That speaks volumes about their work. What's also impressive is how they've made these models accessible to the research community. With open-source tools and APIs available, researchers can experiment and refine these technologies further. Think about it. This collaboration could lead to innovations we can't even fathom yet. As we wrap up, it's essential to recognize that the journey of DeepSeek models reflects the broader evolution in AI. Learning from mistakes, incorporating better practices, and sharing advancements with the community. It's that cycle of growth and community that can pave the way for the next big breakthrough in AI reasoning. Before we go, I'd love to leave you with a thought-provoking question. What do you think the future holds for reasoning models like DeepSeek R1? Could they reshape not just our approach to AI, but also how we interact with technology in our daily lives? Thanks for tuning in to this episode of the Tech Talk podcast. We hope you found this discussion insightful and inspiring. Until next time, keep exploring the fascinating world of technology.